This is the second part of our discussion on how to merge a database table with an Autonumber primary key used by foreign keys. In the first part, we've got familiar with KSDB merge tools and its Id-Remap merge feature that can be used to solve this task. And we looked at an example of merging a few rows from one parent-child tables pair. If you haven't watched part 1, I strongly recommend that you do this before watching part 2. Let's proceed with our next example of using Id-Remap merge. It is based on the same database model that was used for part 1. In part 1, we already did the merge of a few product rows with dependent product log rows. We assumed that we have one common product that exists both in source and target databases, and all other products in the source database need to be merged. Now, let's do something similar for tables client and user. Let's switch to the demo. We continue to work with the same database pair as in part 1, and we can see that our table definition list now contains two more tables in the target. That's our mapping tables for the merged product IDs. Let's check our data for clients table. We see something very similar to what we had for product. We have one common client that we're not going to merge, and two more source-only clients that need to be merged. What's interesting in this case is that our common client is unchanged. And all the remaining data that needs to be merged, it is either new or changed and therefore matches to the new and changed filter. Now, let's check the data for user. We have no common user rows, and we also can see that all user rows match to the new and changed filter. Previously, we had experience of merging selected rows of one table. Now, let's try to merge multiple tables at a time. Let's open the batch data diff, select client and user, and click merge. Application detects that we process tables with Autonumber primary keys that are used as foreign keys, and suggests us to use Id-Remap merge. The dialog also asks which rows we need to merge, only rows that are calculated as new or changed or both. We agree to use Id-Remap, and now it also suggests to process all rows. This filter, new, changed, or all, it defines which rows to take from the source. As we know from part 1, the row is calculated as new if its ID is missing on the other side, and it is calculated as changed if its ID exists on the other side, but it has different values for non-ID columns. And as we saw looking at table data, all the rows that we need to merge, they match to the new and changed filter. In our concrete example, this filter allows processing of all users and almost all clients. We need to exclude from merge only one common client. We assume that this client already exists in the target database, and since it is not changed, it does not match to the new and changed filter. We click OK, and here is what we can see. Our list of tables to merge contains not only client and user, but also order and all other tables depending on order. That's because order has client ID foreign key. In general, if we're not sure why some table is presented in this list, we can check all the previous tables and search for that table in the direct children column. And we see that table client has direct child order. That means that order has a foreign key referencing to client. We also see that there is one table in the other parents list. We ignore this for now, and we'll take a look at this list on the next step. On this step, we need to process only tables client and user. We uncheck order, and it automatically removes selection from all other tables depending on order. Again, we don't select remove new mapping tables because we will need these tables for the next step. Click OK, and here is our merge script. Here we have everything similar to what we have already done for the product table. First script item is a mapping table for client. The next one is a mapping for user. The next two items insert our source-only clients without specifying target ID. And there is another statement to save source ID to the new target ID mapping to our mapping table. The next two items do the same for user records. As we can see, we have no script item for common client, and that's what we need. Click Run and Close, and let's check the result. Our client table has 2 rows from source with new IDs. User table also has 2 rows from source, also with new IDs. And our table list has 2 new mapping tables. Let's check one of them. Source client ID of 2 is mapped to 3 and 3 to 4. That's correct. Now, let's merge all the rest. It is an order table and all order-dependent tables. Let's merge all the orders from the source database. Before doing this, let's open data diff for each table and we will keep them open. After merge, we will do a refresh for each data diff and check what's changed. Go back to the batch data diff, select order and click merge. Agree to Id-Remap, choose all. Because we're merging all orders, click OK. List of tables includes all order-dependent tables. That's what we need. And now it's time to talk about other parents. We see that table order has other parent table client. The word other means here that it is a parent table that was not selected to merge. This points our attention to the fact that some rows from the order table may have some client ID foreign key value that is either missing in the target database or that ID used by some different client. For example, we saw that client ID of 2 was pointing to the different client entities. In the source, it was a source-only client, and in the target, it was target-only client. These rows represent 2 different client entities. Source-only client ID of 2 was merged as ID of 3. And now when we merge some order with client ID of 2, we need to change it to 3. And to achieve this, we have an additional other parents configuration. We already merged client rows and saved mapping for that merge. Now let's choose that mapping. And the same way, for the same reason, let's set up other parents mapping for product and user. The mapping tables that we select from these drop-downs, it is our mapping tables that we have after previous merge actions because we did not select Remove New Mapping Tables. Let's click OK and check our script. The first 3 items are our new mapping tables for order, order item, and order log. We don't have a mapping for order log to order item here because it has no Autonumber key. It has a composite key consisting of order log ID and order item ID. The next script item inserts the order row. And here we can see how other parent mapping works. It is transformed into the coalesce statement. We try to use other parent mapping, and if not found, we use source value as is. This allows us to merge orders for our common client that was existing in the target database from the very beginning. Now let's check the order item script. It uses select from mapping for our order table that we are merging right now, and coalesce statement for other parents mapping for the product table. Again, such a statement allows us to merge order items referencing our common product. We have similar situation for the order log table, coalesce statement for user ID because of other parents. And finally, for order log to order item, we use order log and order item mapping populated by the previous script items. Let's run and check the results. We saw there were 2 orders in the target, 3 in the source. Refresh, and we see that all source order rows are copied to the target with newly generated Autonumber IDs and correctly updated values of client ID. Client ID of 1 is our common client. It was not changed. Client IDs of 2 and 3 changed to 3 and 4 respectively. Now order item, 5 rows in source, 3 in target. Refresh, now 8 rows in the target. Order IDs are updated to the new values. Product ID of 1 is not changed for common product. Other product IDs changed properly to the new IDs. Now order log, 3 rows in the source, 2 in the target. Refresh, now 5 rows in the target. Order IDs and user IDs are updated to the new values. And order log to order item, 5 rows in the source, 3 in the target. Refresh, now 8 rows in the target. Order log IDs and order item IDs are updated to the new values. Well, we are done now with our example. Probably you can say that it is too complex, but it was a complex solution for the non-trivial task because we were using different filters for different tables. To demonstrate that it can be not so complex, let's do another example. But now we will merge all rows from the source for each table. Open another copy of our target database without any changes we made before. Open batch data diff, run it to get current counts. Let's order tables by target DL and open data diff for each table to check result after merge. Select all tables with DL of 0 and click Merge. Please note that with the current implementation, if we want to apply Id-Remap merge, we always need to select tables with the same dependency level. That's because otherwise there can be a logical conflict on what filter should be applied to the child tables. From one side, we have this filter, and from the other side, all the child tables need to be selected with a different filter to include all rows that are referencing their parent IDs. So we use Id-Remap, merge all. OK. All tables selected, that's what we need, and there are no other parents because all the tables are included into the primary list of tables to merge. This time we can remove mapping tables after merge. Click OK. And here is our script. Started with mapping tables, followed by insert to parent tables without specifying ID and saving inserted ID to the mapping. Now we have all the dependent tables using mapping from previous scripts. And finally, we drop mapping tables because we no longer need them. Click Run, and let's check the result. All client rows are merged with new IDs, including common client. Same for product, user, order. We see that all client ID values are changed to newly inserted IDs. Including common client from the source database, we use the new client ID of 3 for it. And the same correct result for the rest of the tables. That's all for part 2. Thanks for watching.